Everyone here is, I guess, everyone else went to sleep or something. You guys are the lucky few. You get to know and understand Lightbits storage is all about, and a little bit about the journey and where we're heading. So that's my smiling face. You don't need to see that anymore. That's a slide on the agenda. We are definitely going to spend time talking about NVMe over TCP. And then a little bit about what's going on, Lightbits, company, technology, and a little bit about the virtualization market, and then show some performance. Because performance is usually what I do. So NVMe over TCP, the left side is actually how you are supposed to write it. The right side is how some people write it, but it is NVMe over TCP. Just a little bit about NVMe in general. It exists in any of the servers that you guys have. Pretty much any SSD that you buy today, you access it through NVMe commands and protocol. And that's been started since 2011-ish. And then 2016, some great minds started to think about, hey, how can we use these NVMe commands to the storage devices remotely over some sort of fabric so we can access them remotely. That's NVMe over fabric, which is a big umbrella of products and protocols. I guess back then the two main ones were you want to use RDMA. So InfiniBand and the guys at Mellanox were pushing for that. Intel with the Rocky and IRAP were pushing in a different direction. RDMA is still heavily used today in some places and a lot in AI nowadays. And then you got fiber channel over NVMe, which is another method of sending NVMe command over regular or not regular, but specialized fiber channel switches and network cards. We at Lightbits thought about doing things a little bit different, so we will be less vendor locking, less specific software or anything like that. So we invented NVMe over TCP, the protocol, and basically donated it into, you can call it a consortium of storage and network companies. Wrote the first NVMe over TCP kernel model for Linux. Got that into the main tree of the kernel. 4.10 is when it started. So unless you're running something really old, any, let's say, 3-4 versions of last Ubuntu's, anything RHEL 8 and above, already have NVMe over TCP, the kernel model inside part of the kernel. You don't need to do it. It's already there. And then today, pretty much all storage vendors have NVMe over TCP access methods into their storage technology, whether it's, really hardware SAN based or whether it's software defined. The big difference between Lightbits and other storage vendors is that target side, the backend on Lightbits was written to use NVMe over TCP, take advantage of that. And other storage vendors, what they're basically providing is a gateway to use with NVMe over TCP with their storage. And so why talk a lot about NVMe over TCP? So first of all, why to use it? Top reason is because we wrote it and we are very smart people and very humble. And the main reason is that the protocol was written in a manner where it wants to take availability of multi-core, multi-queues that runs on multiple cores into the servers, and network cards that by nature, without any kind of adding specific software, supports multi-queues, and again, multi-interactions with multi-cores. So it's essential what you have is a massive amount of parallel streams of TCP going from your client side all the way into the targets. That's the big advantage of NVMe over TCP. Of course, NVMe over Fabric, same advantage, but you get into the specific network cards, sometimes specific network switches, specific drivers, all kinds of software that needs to be installed. So within NVMe over TCP, we said like, we don't want to be dependent on anything. Just all we need is the ability to access send packets over TCP from your client into our targets. That's pretty much it. So a little bit about the Lightbits. The founders and all the companies that we have, not really less interesting. What's more interesting is that the few people that started the company came from 3 different domains. One is that we actually had a few guys that wrote the first NVMe spec, and they were deeply involved with companies that were manufacturing flash storage, like the flash media itself. We have people that came from the network world and people that came from the clustering. That's what's really unique about Lightbits. It's kind of like the pillars of our software and where and how we are building things. We talked about the NVMe over TCP side, so no need to talk about this. We wrote our own flash translation layer, so we manage the flash devices, the SSD and NVMe devices on the target side in a much more efficient manner than just letting Linux or any software write to it, which in return enhance the lifespan of the SSD devices. Also heavily reduce the amount of garbage collection that these devices are doing, because we are doing smart writing and we are doing our own garbage collection. And flash translation layer is not something easy to write. And the third pillar is the clustering side. The company actually started first the technology in a single node manner, and then we added the clustering. And the clustering basically means that when you create a volume in Lightbits, you can choose whether it will have 1, 2, or 3 replicas. That's really up to you. A minimum cluster of Lightbits is 3 targets. And with clustering, we're able to achieve a resiliency at the cluster level. With the flash translation layer, and also we have local erasure coding on each of the targets, we're able to sustain resiliency at the target level. So you lose a SSD, and there's no impact on performance, there's no impact on this. So where I kind of mentioned it's software-defined storage. We do have a marketplace offering in Azure and AWS, support any kind of a hardware vendor that you want to buy, whether it's white boxes or any of these fellows in here. And some of these are actually investors in Lightbits. From infrastructure perspective, I know I shouldn't say VMware in here, but we actually helped VMware write the first NVMe over TCP driver. We have Cinder drivers for 4 years, Kubernetes, so CSI drivers also about 4 years, all supported. Pretty much the majority of our customers are running Kubernetes, and then the rest of them are running either OpenStack or bare metal. And then the what. So when you look at the Lightbits and what we provide, because we provide such high throughput, a lot of IOPS with low latency, sometimes we get these databases that are really consumers of a lot of IOPS and they can take advantage of a low latency. And sometimes it's just hundreds or thousands or hundreds of thousands of pods running in Kubernetes and consuming IOs from a single cluster of Lightbits. This is kind of a simple scheme of how Lightbits is kind of the flow of IOs and what's going on. But what you can see here is that when using NVMe over TCP, the volume that we create and you attach into your client has access into all the targets in the cluster that has copies of that particular volume. So it doesn't need access to all the targets, only those that have copies of that. And if something happens into one of these targets, then all IOs just continue to flow into the other replicas of that volume. That's all part of NVMe over TCP. All right, I'll go over this pretty fast, but it's kind of our architecture design in terms of what's going on in a cluster and in a single target. We divide everything into between the work of the front end and the back end. The back end we talked a little bit. That's our flash translation layer. That's where we're doing rich recording and all sorts of error detections and things like that. Front end basically handle all the traffic that comes from the client and also all the traffic that gets replicated into the other targets. And by the way, all this traffic is compressed, so even replication traffic is compressed, and you're basically reducing the amount of network usage for that. We offer, of course, API access, REST API into the cluster, export all sorts of information and metrics with the Grafana and Prometheus. The ability, of course, to upgrade the cluster online, do rolling updates, all of these things that you want to see from a storage solution. So let's talk a little bit about the performance. These are kind of hero numbers, but just to put some perspective, the top row here is read-only. Block size is 4K. This is 3 servers of Lightbits providing 14 million of 14 million of 4K reads. So we're roughly about 4.2, 4.1, sometimes even more per target. And you can see what we've done in here is with 24 Linux clients. There's there's dual 100 gig network adapters on the target side and dual 25 gig on the client side. We really don't care what you're going to have on the client side. Of course, it's going to impact your performance. What's more important is what you're going to have on the target side. What is really nice is that, of course, when you use everything and there's like a gazillion of IOPS, your latency go up. But in this case, we're showing almost 4 million IOPS 4K reads, and you can see the average latency and especially the tail latency are really low. And by the way, this was with the replication factor of 2. So these are some performance numbers that we recently did versus Ceph. It's getting harder and harder to actually test any software in terms of comparison of numbers. But Ceph, everyone can use, and it's working Red Hat and did 2 years on Rook and Ceph. What we're showing here is basically the top side is application factor of 2, the bottom side of application factor of 3. There's 1 to 16 VMs on a single OpenStack client, and the blue line or the blue columns are basically the IOPS, the total IOPS from that client, single Linux server. So with 16 servers, you can see that 936K with RF2. You can see almost the same number with a replication factor of 3. It doesn't change much. And you can also see the difference between what we were able to achieve on from the same 3 servers of Lightbits that were running Lightbits, running Ceph, versus what we can achieve with the Lightbits. This next one is basically doing it at the cluster level. So we started to add for one OpenStack server that has 16 VMs running on it. We started to add more clients into the OpenStack cluster. And you can see how we are slowly growing the Lightbits, the IOPS that these clients are all together able to achieve from the Lightbits cluster. Ceph, in that sense, on the same 3 servers is very limited. If you want to achieve the same number of IOPS on a Ceph cluster, do the math, you probably need 10 times the servers, if not more, to get to that. The bottom one is basically the averages per client, and as you can see, the average of a client with one client, it's the same number. With 2 clients, it's a little bit growing, and so on. And with the nice thing about Lightbits, roughly around client number 4, we reached the limit of what the Lightbits cluster with only 3 targets can provide. You want to increase your IOPS performance or bandwidth, just add more targets into the Lightbits cluster. Performance grows linearly. This is a study case that one of our customers did, Crystal AI Cloud, also versus Ceph. But what I really want you guys to take from this is that what we have built in Lightbits and where we're seeing our customer going, either the applications that really can consume IOPS with low latency, or what we see a lot is kind of a bottomless box that provides IOs and throughput to massive clusters, whether it's an OpenStack with hundreds of VM, or whether it's a Kubernetes with thousands of pods and containers. That's how our customers are looking at this. Our largest customer is running roughly about 18,000 workloads of Kubernetes from on several clusters, of course, of Kubernetes, from a little bit more than 16 or 17 clusters of Lightbits. But we provide block for all these Kubernetes clusters. And the footprint, that is the key here. The footprint in your data center, the power, the cooling, all of these things are immensely reduced if you were using a different technology. And I think that's about it. Anyone has any questions? All right, I'm still here if you have. Thank you.